Now in complex analytic function, we'll be looking at the gate questions of a Cauchy's integral theorem and Cauchy's integral formula. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Now coming to the next question. The question is, if f of z is equal to c naught plus c1 z inverse, then integrate over closed curve 1 plus f of z by z dz is given by. Okay, we have to find this one. Now for this one, you have to use the Cauchy's integral formula. It is given as integral over closed curve f of z by z minus a whole power n plus 1 dz is equal to 2 pi I by n factorial into f of n of e, right? Now it is substituting the same thing here also. First what you do is nothing but substitute the value of z, which is equal to c naught plus c1 z inverse. So we get nothing but integral over closed curve c 1 plus c naught plus c1 z inverse by z dz. Expand this particular integration. It becomes integral closed curve c 1 by z dz plus integral closed curve c naught by z dz plus integral closed curve c1 by z square dz, right? Now defining value of n and e value and substituting this particular equation. Here n is equal to nothing but 0, right? We know that z minus a n plus 1. So it is given as z minus 0. So we can consider a is equal to 0 and n plus 1 should be equal to 0. Then n is equal to nothing but 0, right? So here it becomes nothing but 2 pi I by 0 factorial into f dash of an a means no need of any differentiation. So it becomes nothing but 1 such that z is equal to 0. We have to substitute, right? Plus the second term 2 pi I. Again n value is nothing but 0 and e value is equal to 0. So 2 pi I by 0 factorial into it becomes c naught. And we have to substitute z is equal to 0 plus 2 pi I. N value is nothing but it becomes 1 as we have z square, right? And e value is nothing but 0. So it becomes 2 pi by 1 factorial into f dash of an e value. We have to consider f dash of e is nothing but here it becomes c1, right? c1 d by dz, and we have to substitute z is equal to a here, right? So which is equal to 0 factor is 1 and we are multiplying with a 1, so it becomes 2 pi I, and we don't have any z terms here, so it becomes plus here also 0 factor is 1 and no z terms, so it becomes c naught, so it becomes 2 pi I into c naught plus differentiation of c1 is nothing but equal to 0, so it becomes 0, so the whole term this one becomes a 0, so it becomes 0, which is equal to it becomes a 2 pi I common, so it becomes 2 pi I into 1 plus c naught, right? But it is given in terms of g. I or j are same. So answer option D. Next question. The question is the value of contour integral of closed curve 1 by z square plus 4dz in a positive sense of mod z minus j is equal to 2. They're asking, right? For this one, you have to know about the Cauchy's integral formula. Given as integral of closed curve f of z by z minus a whole power n plus 1, which is equal to 2 pi I by n factorial into fn of a, right? This is a general formula you have to know, right? But you have to consider that a should be inside the circle, right? Now they are given the function here. It is given as integral of closed curve 1 by z square plus 4 dz, right? We can write this one as nothing but integral of closed curve 1 by z plus 2j, and the other one is z minus 2j dz. Now we'll be looking which of the pole will be inside the circle. Now coming to the poles. Here we can see that poles are nothing but z is equal to minus 2j and z is equal to 2j. Now it should be inside the circle of an mod z minus j is equal to 2. If you consider graph here, the real part of an z and there's an imaginary part of an z, right? Now it is centered at the somewhere at the j, right? Now what we do is nothing but check if the poles are inside the circle or not. If it is outside the circle, it becomes 0, right? So first check for z is equal to minus 2j. So it becomes mod of minus 2j minus j should be less than 2. Then it comes inside the circle. So it becomes minus 3j mod should be less than 2. You can see that it is 3 less than 2. It's not satisfied. So we can see that minus 2j will be outside the circle. Now coming to z is equal to 2. Substitute here. We get mod of 2j minus j should be less than 2. Then it comes inside the circle. So it becomes mod of j should be less than 2. Once 1 should be less than 2. It got satisfied. So we can say that it is somewhere. 2j will be somewhere here. As we have a radius as an given as nothing but 2. So border will be 3j, right? So only 2j is inside the circle, right? So you have to substitute the values here. Equate this one to here. Cauchy's integral formula. We know that f of z becomes nothing but 1 by z plus 2j, right? And z minus a whole power n plus 1. Z minus a whole power n plus 1 is equal to z minus 2j, right? So from here we can see that a is nothing but 2j and n is equal to 0. So substituting this particular formula, we get as 2 pi I by 0 factorial into n is 0. So no need of differentiation. It becomes 1 by z plus 2j. And you have to substitute z is equal to 2j. So which is equal to 2 pi I means it is j only. Okay. I or j. It becomes 2 pi j into 1 by 2j plus 2j. It becomes 4j, right? J get cancelled. One side it goes by 2 side, which is equal to pi by 2. So answer is option D. Now come to the next question. The question is the integral of closed curve f of z dz evaluate around a unit circle on a complex plane for f of z is equal to cos z by zs. Okay. So they are asking for the integration of a closed curve cos z by z dz such that it is a unit circle. So it becomes mod of z is equal to 1. Right. Now general formula we use it. The Cauchy's integral formula given as integral closed curve f of z by z minus a whole power n plus 1 is equal to 2 pi I by n factorial into fn of a. Right. Now first we'll checking the pole. You can see that z is equal to 0 as a pole, whether it is inside the circle or not, else it becomes 0. So you consider a circle. Okay. It is centered at the origin, right? And its radius is given as 1, right? Now z is equal to 0 is pole in the center only. So we can use this particular formula. Now you can see that f of z is equal to cos z and z minus a whole power n plus 1 is equal to z, right? So we can see that n is equal to nothing but 0 and a is equal to nothing but 0 only. So substitute here, we get 2 pi I by 0 factorial into f of a, right? F of 0 you have to substitute. N is 0, so no need of doing n differentiation. So it becomes 2 pi I, 0 factor is 1 into cos, f of z is cos z, right? F of 0 means cos 0 cos 0 is equal to 1. So it becomes 2 pi I. So answer option A. Next question. The question is, using Cauchy's integral theorem, the value of an integral. Okay. The given integration being taken in unit counter anticlockwise direction. And you have to consider integral of closed curve z cube minus x by 3z minus I dz. Right. So we have to find the value of integral of closed curve z cube minus x by 3z minus I dz. You have to know the Cauchy's integral theorem given as integral of closed curve f of z by z minus a whole power n plus 1 is equal to 2 pi I by n factorial into fn of a. Right. Now we'll be checking whether the pole is inside the circle or not. We can write this particular equation as nothing but integral closed curve z cube minus 6 by 3 taken common z minus I by 3. Now we have to check whether the pole, we get the pole as nothing but z is equal to I by 3. Right. You have to check whether it is in the circle mod z is equal to 1 or not. So if you consider this particular graph here, is a real part of an z, is an imaginary part of a z. It is centered as an origin, right? And they given the radius as nothing but 1. Now I by 3 would be inside the curve. So we can use this particular formula. So we can see that by equating these particular, both of them, we get f of z is equal to z cube minus 6 by 3. And the other one is z minus a whole power n plus 1 is equal to z minus I by 3. So we can say that a is equal to I by 3 and n is equal to 0. So we'll be using this particular formula. Then we get 2 pi I by 0 factorial into, at 0, n is 0, so no need of doing any differentiation, into z cube minus 6 by 3, and we'll be substituting z is equal to I by 3. So 0 factor is 1, so it becomes 2 pi I into, here it becomes, if you take 3 outside, it becomes I by 3 whole cube minus 6 into 2 pi I by 3. One side goes 1, 2 side. I cube is nothing but minus I, right? I cube is equal to minus I. Again we are multiplying with an I, so it becomes nothing but a I power 4 is equal to 1. So which is equal to 2 pi by 3 cube is 27 into 3, it becomes 81 minus 4 pi I. So it is moving in an anti-clockwise direction. So it is moving in this particular direction. So answer option A. Now come to the next question. The question is, consider the liking applicability of Cauchy's integral theorem to evaluate the following integral contour clockwise around the unit circle C. I is equal to integral of closed curve secant z dz, where z becomes a complex variable. The value of I will be. Okay. Now they are given that I is equal to integral of closed curve secant z dz. And they're talking about a unit circle. So mod z is equal to 1, right? If you consider f of z is equal to secant z, then we can write this one as 1 by cos z. Now the first finding the similarities. Okay. First finding the similarities. And we have to find the value of I also, right? Now when does it cos z becomes 0? It becomes infinity, right? F of z becomes infinity when cos z is equal to 0. So cos z is equal to 0 when, if you consider z is equal to plus or minus n plus 1 by 2 pi, right? Now where n will be varying from 0, 1, 2, 3, so on. Okay, n is equal to 0, 1, 2, so on, you get it. right? Now we're checking whether this particular poles will be inside the circle mod z or not. Okay. Now if you consider axis here, we can see that this is a real part of an z and this is an imaginary part of an z. Now they are given mod z is equal to 1. Once it is centered at an origin and its radius is given as 1. We have to check which of the poles will be inside this particular circle. Now if you apply n is equal to 0, 1, 2 or 3, it always will be greater than 1. So all these particular poles will be outside the unit circle, right? Will be outside the unit circle. So we know that when the poles are outside the unit circle, the Cauchy's integral theorem states that integral closed curve f of z dz will be equal to 0. So we can say that integral 1 by cos z dz will be equal to 0, right? And coming to the singularities, okay. Now you can see that the singularities are there, but none of them are inside the curve. So we can say that singularities are nothing but 5, right? 5 means 0. So answer is option A. Now coming next question. The question is the value of integral or closed curve cos 2 pi z by 2z minus 1 into z minus 3 dz, where C is in a closed curve given by mod z is equal to 1. So what they are given as nothing but integral of closed curve cos of 2 pi z by 2z minus 1 into z minus 3 dz, right? Now we can use in a cos is integral formula given as integral of closed curve f of z by z minus a whole power n plus 1 is equal to 2 pi I by n factorial into d by dz n times of an f of z, and we have to apply z is equal to a, right, after differentiation. Now first we'll be finding the poles of it. We can see that the poles are nothing but z is equal to, in the case of 2z minus 1 it becomes 1 by 2, right, and in the case of z minus 3 it becomes 3. Now they are given the closed curve of mod z is equal to 1, right? You have to find the closed curve for mod z is equal to 1. So we'll be checking which of the poles will be inside the circle or not. If you consider a circle here, the real part of an z and this is an imaginary part of an z. Now mod z is equal to 1. So it will center at origin and radius is 1. So if you consider pole 1 by 2, it will be inside and 3 will be outside, right? So we will consider only 1 by 2 and substitute the values, right? So on this one, we can write this particular equation as nothing but integral closed curve cos of 2 pi z by z minus 3 into 1 by 2z minus 1 dz, right? From this one, we will find the value of f of z, a and n, right? Now from here we can see that this particular value is nothing but f of z, right? Now z minus a form should be there. Z minus a whole power n plus 1 form it should be there, right? So we can write this particular form as nothing but integral of closed curve cos of 2 pi z by z minus 3 into 1 by 2 into z minus 1 by 2, right? So from here you can see that it is in the form of z minus a whole power n plus 1. So we can see that this is nothing but f of z, right? And a is equal to nothing but 1 by 2, right? And n is equal to 0. So just substitute values here. We get as 2 pi I by 0 factorial into, Now n is 0, so no need of using differentiation. From the f of z, it becomes cos of 2 pi z by z minus 3 into 2 also comes into picture, right? Of z is equal to a is nothing but 1 by 2. So which is equal to 2 pi I into, substitute the values here. 0 factor is 1. So it becomes cos of 2 pi into 1 by 2 by 2 into, here it becomes 1 by 2 minus 3. Right? 2 get cancelled here and 2 get cancelled here. Cos pi is nothing but minus 1. Right? So it becomes minus pi I by, here 1 by 2 minus 3. Once it becomes minus 5 by 2. Minus minus goes, becomes plus, which is equal to 2 pi I by 5. So integral of closed curve cos 2 pi z by 2z minus 1 z minus 3 using a Cauchy integral formula. It as 2 pi I. Answer is C. Now come next question. The question is the value of integral of a complex function f of s was equal to 3s plus 4 by s plus 1 into s plus 2. Along the plane mod s is equal to 3. What they are saying nothing but find the integral of closed curve for mod s is equal to 3 for 3s plus 4 by s plus 1 into s plus 2 ds, right? Just they have changed z to s. That's it, right? For this one, you have to know the Cauchy's integral theorem and Cauchy's integral formula. Okay. First, we'll be finding the poles. Okay. You can see that s is equal to minus 1 and minus 2 are the poles. We'll checking whether they are inside the circle or not. For mod s is equal to 3. If you consider a graph here, there's any real part of an z and there's an imaginary part of an z. And they're given that radius of this one is nothing but 3, right? Then minus 1 and minus 2 would be coming inside the circle, right? So we can use a Cauchy's integral formula, right? But first we'll be splitting this particular function f of z. Okay, as we know that 3s plus 4 by s plus 1 into x plus 2, right? Which is equal to nothing but a by s plus 1 plus b by s plus 2, right? We can write in this particular format. Now when we have s is equal to minus 1, then we get a into minus 1 plus 2 is equal to 3 into minus 1 plus 4. So from here we can say that a is equal to nothing but 1. Now coming to s is equal to minus 2. Then we get b into minus 2 plus 1 is equal to 3 into minus 2 plus 4, which is equal to minus b is equal to minus 2, which implies b is equal to 2. So we can write this particular function as nothing but integral closed curve mod s is equal to 3 1 by s plus 1 ds plus integral closed curve for mod s is equal to 3 2 by s plus 2 ds, right? We know the Cauchy's integral formula given as integral closed curve f of z by z minus a is equal to 2 pi I into f of a, right? So substitute here in both the term. So we get this term is nothing but it becomes 2 pi I into 1 plus here it becomes 2 pi I into 2, which is equal to 2 to the 4, 4 plus 2 6 pi I, right? Now here it is given as j. Okay, so I is nothing but j, so answer option C. Now come next question. The question is contour C is adjointly figured and described by x square plus y square is 16. The value of integral of closed curve z square plus 8 by 0.5 z minus 1 0.5 j dz is. Okay, now they are given that x square plus y square is equal to 16. We know that z is equal to nothing but x plus iy, right? And mod of z is equal to under root of x square plus y square. So from here we can see that it is equal to nothing but under root of 16, which is equal to 4. So we can see that the circle is nothing but mod of z is equal to 4 as in a contour circle C. Now we have to find the value of integral of a closed curve z square plus 8 divided by 0.5z minus 1.5 g dz, right? For this one, you have to know the causes integral formula, right? So first we'll be looking at the poles, okay? We can write this particular term as nothing but integral of closed curve z square plus 8 divided by, if you take z.5 common, it becomes z minus 3j, right? dz. Then the pole is nothing but z is equal to 3j, right? We're checking whether it is inside the circle of an F4 or not. If you consider graph here, real part of z and imaginary part of an z, and they given the radius as 4, right? The radius is given as 4. Now coming to 3j, where the 3j will be? Somewhere here it will be 3j. So it is an inside the circle. So we can use a causes integral formula. Given that integral closed curve f of z by z minus a is equal to 2 pi I into f of a. So here you can see that f of z is nothing but z square plus 8 by 0.5, and a is equal to 3j, right? So the substitute here we get 2 pi I into, it becomes z square plus 8 by 0.5 at z is equal to 3j, right? So which is equal to, it becomes here 0.5, when you bring it up it becomes 2, 2 into 2 it becomes 4, 4 pi I into, it becomes 3j whole square plus 8. You know that j square is not but minus 1, right? So it becomes 4 pi I into minus 9 plus 8, right? Which is equal to, it becomes minus 4 pi I. Instead of I, they are given as a j, okay? Don't get confused. I is equal to nothing but j only, okay? So answer the option D. Next question. The question is the value of integral closed curve C dz by 1 plus z square, where z is in a contour. Z minus I by 2 is equal to 1. So they are asking the value of integral closed curve C dz by 1 plus z square, right? We can write this one as nothing but integral closed curve of C dz by z plus I into z minus I, right? Now we have to find the integral of this one. They given the contour as z minus I by 2 is equal to 1, right? So we're checking with the poles, which of the poles will be inside the circle or not, okay? The poles are nothing but I comma minus I, right? If you consider graph here, there is real part of an z, this is an imaginary part of an z. This is x, this is I by 2, right? Now I by 2, it is centered at I by 2, and the radius is nothing but given as 1, right? Now if you consider I here, if it comes inside the circle or not, how to check it? There's nothing but, we know substitute I in this particular equation, it becomes mod of I minus I by 2 should be less than 1, then it will be inside the circle. So here it becomes nothing but mod of I by 2 should be less than 1. So 1 by 2, it will be less than 1. So I is inside the circle, okay? Now coming to minus I. So mod of minus I by 2 should be less than 1. So we get as minus 3I by 2 less than 1. So it is nothing but 3 by 2 less than 1, not satisfied. So we can say that minus I is outside the circle. So we have to find only for z minus I, right? For this one you have to use the Cauchy integral formula. As we know that integral closed curve f of z by z minus a is equal to 2 pi I into f of a, right? Now f of z is nothing but, here it becomes f of z is equal to 1 by z plus I, right? And a is equal to nothing but I, right? So substitute here we get 2 pi I into 1 by z plus I, z is equal to I, right? So which is equal to 2 pi I into 1 by I plus I, which is equal to 2 pi I into 1 by 2i. I get cancelled, 2 get cancelled, which is equal to pi. So answer is option B.